up guys? So welcome back to Unit 5. So we're moving on into Lesson 5.2, which is going to be something called simplifying radicals. This is going to be a tool that's going to help you whenever you're doing Pythagorean theorem, when you're doing special right triangles, and also whenever you move up to Algebra 2, this is going to be a tool that you'll be able to use to help you solve problems and to help you figure out things a lot easier, okay? So let's jump into it. All right, guys, so the first thing I'd like to talk about is exactly what I mean by simplifying radicals. So first off, a radical is going to be some type of square root symbol. A radical looks just like that. So anytime you see this symbol, a square root symbol, a cube root, a fourth root, a fifth root, anything of that sort, this symbol right now is known as a radical, okay? So what we're going to be doing is we're going to be taking radicals and we're going to be simplifying them, okay? Making them in their simplest form. What we mean by that is you can take a fraction and you can reduce the fraction or make it smaller to make it a simpler number, something easier to work with. So we're simplifying it to make it easier to work with. So that's what we're looking at now, okay? So the first example we're going to look at is we're going to look at the square root of 16, okay? So right now, this is a radical because I have my radical symbol going over that 16, okay? So the first thing I want to explain is what I mean by square root. So we all know what squaring is. So like if I took 3 squared, I know that I'm going to be multiplying 3 twice. So 3 times 3 is going to equal 9. Right now, if you look, this number right now, 3, that's going to be the root of the square. So that means if I was to square root 9, it would turn into 3. So the square root of 9, if I squared 9, it's going to give me 3, okay? So let's go ahead and do 16. So right now, the square root of 16 is going to be 4 times 4. So I know 4 times 4 is going to equal 16. So that means the square root of 16 is going to be 4. So your final answer on that would be 4 because you're square rooting that, okay? So that is known as a perfect square. So right now I have a list all the way from 0 to 19, a list of perfect squares that you're going to be putting into use here in a little bit, okay? All right, so here we go. So now let's look at the square root of 32. So the square root of 32, if you look over here, I do not see the number 32 over here anywhere. So that means 32 is not a perfect square. But what I can do is I can break it up into 2 different radicals to try and find a perfect square within that 32, and then I can simplify it further to help me out, okay? So what I'm gonna do is I'm gonna find out which one of these perfect squares can actually go into 32, meaning divide into 32, okay? So the highest number that can divide into 32 is 16, okay? So if I actually do 32 divided by 16, that's gonna give me 2. So what that tells me is 2 times 16 is gonna give me 32. So what I'm initially gonna do is I'm gonna take this square root of 32 and I'm gonna break it up. I'm gonna break it into the square root of 16 and I'm gonna break it into the square root of 2. Because 16 times 2 gives me 32. So I broke it up into 2 different multiples, okay? So now I'm going to simplify it further from there. So right now, I can't do the square root of 2, but I know the square root of 16, we just did it over here, turned into 4, right? Square root of 16 gave me 4. That's the square root. So that means the square root of 16 is going to turn into 4 square root 2. So I would just bring that down. So that means the square root of 32 is going to simplify to 4 square root 2. Okay? So basically you're finding the highest perfect square that can go into that. All right? Let's jump into the examples. All right, so right now, square root of 125, we were trying to simplify this. So right now, if you look at your perfect squares up in the top right-hand corner of your paper, 125 is not a perfect square, so it can't just square out evenly. So what we're going to do is we're going to find which one of those perfect squares will divide evenly into 125. The biggest square that will divide into that is 25, okay? Because 25 times 5 is going to give you 125. So what I'm going to do is I'm going to take this radical, I'm going to break it up into 2 different ones. So the square root of 25 when multiplied by the square root of 5, 25 times 5 is going to give you 125. So now I can break this up even further because the square root of 25 is going to give me 5. And then I don't have a square root of 5, so I'm going to bring down the square root of 5. So right now, the square root of 5 cannot be broken down any further because none of those perfect squares can divide evenly into 5. So your final simplification is going to be 5 square root 5. Because just to let you guys know, if you plugged in the square root of 125 and got a decimal and plugged in 5 times the square root of 5, it's going to be the same number. Simplifying it still means it's the same thing, okay, technically. All right, so let's jump over to example number 2. On example number 2, we already have a number outside the radical with the square root of 54 here, okay? So right now I need to think, which one of those perfect squares will divide evenly into 54? Okay, so that number is going to be 9 because 9 times 6 is going to give you 54. Okay, so right now I'm going to break this up. So I have 5 out there. I'm going to do the square root of 9 and then the square root of 6. Okay, so right now I can reduce 9 by the square root of 9 is going to give me 3. So this is going to turn into 3, which I would then end up multiplying those. Okay, and square root 6. There's not a radical or a perfect square that can go into 6, okay? So right now, 5 times 3 is going to give you 15. So that means the simplification of 5 square root 54 is going to give you 15 square root 6, okay? All right, next one I have on example number 3 is you have 2 multiplied by the square root of 24, okay? So right now, we're trying to figure out what number when divided into 24, which one of those perfect squares will divide perfectly into 24, okay? So right now, the perfect square that'll divide evenly into it is going to be 4, okay? Because 4 times 6 is going to give you 24. So I'm going to break it up. 2 square root 4 square root of 24, or not 24, square root 6, sorry. Okay? So now, square root of 4 can reduce to 2. So I'm going to turn in this into 2 times 2, square root 6. 2 times 2 is going to give you 4. So the simplified version of 2 square root 24 is going to be 4 square root 6. All right, and lastly, I'm going to show you how to simplify whenever you have a radical as your denominator. So if you're getting a final answer, your final answer cannot have a radical on the bottom, meaning the square root symbol or anything like that on the bottom. So what we're going to do is initially we're going to try and get that to show up on top. So your final answer cannot have a radical on bottom. And the way we're going to do that is we're essentially going to multiply by 1. So if I end up multiplying by 1 by anything, it's always going to be the same thing. So like 1 times 2 is going to give you 2. 3 times 1 is going to give you 3. Anything multiplied by 1 is always going to give you the same thing. So initially what I'm going to do is I'm going to multiply by what radical's on the bottom. So I'm going to multiply by the square root of 2 over the square root of 2. Because anything divided by itself is always 1. So initially I'm multiplying by 1 here. So I'm just going to multiply straight across. So 4 times square root of 2 is going to give you 4 square root 2. And then square root of 2 times square root of 2 is going to give you the square root of 4. Well, I know the square root of 4 is going to be 2, right? So this is going to turn into 4 square root 2 over 2. And then I can also divide this. 4 divided by 2 is going to be 2. So this is going to turn into 2 square root of 2. So the simplified version of 4 over square root of 2 is going to initially turn into 2 square root 2 because it looks a lot cleaner than that having a root on the bottom, okay? So again, you cannot have a root on the bottom, a radical on bottom, so this is how we turn it into its simplified form, okay? So guys, hop over to your skill check. Let me know if you need any help.